For this question, we have as the forward bias voltage across a PN junction is increased, the potential barrier will what? So we have the following options here. Now we're going to look at the notes right here, page 43, linked below the like button. And we have these three different possible things we can choose from. So we have an open circuit, and this is at our equilibrium. The next is when we have a reverse bias. And a PN junction in reverse bias is when we have our V on the P side, so the voltage going through like this, and then this is less than the voltage on the N side. So P side is actually like this, and then our voltage side like that. So I got it mixed up. So the V on the P side is going through like this, it's our ID. The voltage on the left side going through here is our IS. Now the VF, which is the forward bias, a PN junction and forward bias, it's the opposite. So with forward biased, our ID, which is going to the left, is going to be greater than the V on the N side. So that is our IS. And how I like to remember this is that, well, for forward bias, we have our just the ID, the part that's going from left to right, because we read from left to right, we have that going to the right. And this is forward. So we're going forward that way. So if we look at our problem again, there's a few main things that stand out. We have a forward bias voltage. So we know that we're going to be dealing with bias voltage, and we know that specifically it's going to be the forward bias voltage. It's across a PN junction, and it's increased. So across our PN junction increased, what's going to happen? And we have the potential barrier. That's another keyword. So when we look at here, we see that depletion region, width, and potential barrier both decrease. This is the middle part right here. With our reverse bias, the depletion region, width, and potential barrier are going to increase because our ID is smaller than our IS. When our ID is bigger, then the potential barrier is going to decrease because we have more of this forward bias going in this way. And so that means that the answer for this one is not stays the same. That would be more of the first one when we're at equilibrium. It is not going to increase because that is when we have a reverse bias. It's not none of these, and we can determine, and it is going to be decrease. So number C, decrease, is going to be our answer.